day, class. So today we're going to start our lecture for the final term. So this is an introductory lecture about sewage treatment plants. I think our last lecture is about a natural sewage treatment plant application using the reed bed system. But for uh, for the next topic, we're going to discuss about the conventional STPs, because it's important for you to have an idea as future architects. So conventional sewage treatment plants, so the conventional plant's performance is usually measured by reductions in suspended uh, matter, BOD, or biochemical oxygen demand, and bacteria. So the processes in conventional plants include: the first is what you call the pre-treatment, second is settling, the third is chemical treatment, the fourth is biological oxidation, the fifth is disinfection, and the sixth is sludge conditioning and disposal process. So in the selection of specific processes and plant design, so these points must be considered. So first is the existing and potential regulatory standards. In the Philippines, we have the National uh, Sanitation Code and the National Plumbing Code. So two, the plant operator's requirements and availability. The third is existing and projected sewage flow. The fourth is the flow pattern and waste characteristics. Fourth to fifth is the climate. Sixth is topography. Seventh is the availability of land. And eight, the plant location within the community, and then all aspects of cost. Because you don't want to design a sewage treatment plant that would be too expensive. So in the pre-treatment process, the objectives are: one, to protect pumping equipment; two, control and monitor instruments; number three, prevent clogging filters. Then the pre-treatment equipment includes: you have the screens, grinders, skimmers, and deep chambers. So flow equalization is also a pre-treatment process. The second, the settling or clarification. So first is to remove settleable solids by gravity. Second is a rectangular or square tank. The third is settling tanks are commonly designed based on where A, the overflow rate; B, the unit flow of volume of flow, or the gallons per day per square foot; then the detention times for settling. So the chemical treatment, so the addition of chemical coagulants is an effective way to improve the settling characteristics of suspended solids. So this process may also be a feasible alternative to: one, improve the efficiency of existing and or overloaded settling basins. So these are the comparison of advantages and disadvantages of the more common coagulants, which is presented detailed below. The first coagulant is alum. The advantage that it is easy to handle and apply, and most effective between pH 6.8 to 7.5. The disadvantage is that it adds dissolved solids to water, then it's effective over a limited pH range. The next coagulant is ferric chloride. So it's effective between pH 4 to 11, also makes sludge dewatering. The disadvantages is that it adds dissolved salts to water. The next coagulant is ferric sulfate, which is effective between pH 4 to 6 and 8.8 to 9.2. So it adds dissolved solids to water, usually need to add alkalinity. The next coagulant is ferrosulfate, which is not as pH sensitive as lime. So it adds dissolved solids to water, usually need to add alkalinity. So the next is lime, is commonly used, very effective, may not increase TDS, then sludge dewaters easily. So it's very pH dependent. Its disadvantage is produces large quantities of sludge and overdose can result in poor effluent quality. So I remember class back in 2010 or 11, there was a project which used this line for waterless what you call this, flushing of the toilet. Instead of water, they use lime to mix with the feces. Okay. The next coagulant is polymer. So a small dosage usually needed, easy to handle and feed. The disadvantage is that improper dose results in poor flux formation. So the fourth is the biological treatment. So there are two basic techniques. First is the fixed bed. So the trickling filter as a fixed bed of stone or plastic packing material that provides a growth surface for specific bacteria and other organisms. Next is the fluid bed. So the activated sludge processes and sewage lagoons are fluid bed systems. So for trickling filters, so trickling filters are the most common treatment units by municipalities to provide aerobic biological treatment. Then trickling filters are classified according to 1. Hydraulic, and 2. Organic loading applied. And for activated sludge processes use continuous agitation and artificially supplied aeration of settled sewage together with recirculation of a portion of the active sludge that settles in a separate clarifier back to the aeration tanks. So these processes vary in 1. The detention time, 2. The method of mixing and aeration, 3. The technique of introducing the waste, and 4. The recirculated sludge. And for oxidation ponds, lagoons and ponds have many applications ranging from complete blue waste treatment to polishing as secondary plants effluents. So the applications do not use metal or concrete tanks. A lagoon is a pond of design that receives waste that has not been settled or exposed to biological exudation prior to entering it. So fifth, we have disinfection. So conventional treatment plants use chlorination as the final treatment process to reduce bacteria concentration. So disinfection involves the destruction of disease-causing organisms. The most common means of wastewater disinfection is chlorination. Okay, so I think you are familiar with this class, especially with our drinking water from the water district. So it's commonly treated with chlorine, and it's also a method used in treating swimming pools. So the sixth is the treatment of drainage sludge. So the solid material deposited in the settlement tanks is known as sludge. So it is a thickish first, then it's offensive smelling, then it's liquid with a water content ranging from 60 to 95%. So let's discuss thickening. So thickening is the first stage in treatment is to remove as much water as possible in order to reduce the volume of material. As the water is removed, the solid concentration increases. Next is dewatering. So this is the process which increases the solid concentration up to 40%, and known as dewatering. Improvements in dewatering technology has led to the production of drier cakes. So dewatering is carried out using either centrifuges, belt presses, or plate presses. Next is enhancement. So enhancement processes do more than simply remove water, and they fundamentally change the nature of the sludge itself. So there are two processes. The first is anaerobic digestion, and next is composting. Okay, so wastewater can be grouped into the following categories, guys. The first is urban reuse for irrigation of public parks. Next is agricultural reuse, so irrigation of non-food crops. Then we have recreational impoundments such as ponds and lakes. Then you have environmental reuse, that's creating artificial wetlands. Then for industrial reuse, process or make-up water and cooling tower water. So the next video class is a short video on how wastewater treatment plants works.
Cities and towns have sewerage systems in place to carry the wastewater from our homes, hotels, factories, and other establishments to a sewerage treatment plant where the wastewater is treated. It is then deemed safe to release into other water sources. The treatment of wastewater goes through different stages. Wastewater is treated to remove the physical, chemical, and biological contaminants present in it through various processes. The pre-treatment process involves the sewage being sent through grids or vertical bars that can remove large solid substances like metal cans, paper, and plastic materials. In primary treatment process, the sewage flows through the grit chamber very slowly so that the sand, pebbles, and soil settle down at the bottom. The sewage flows into the settling tank or sedimentation tank, where the solid wastes like feces are allowed to settle down. Wastes such as soaps, oils, and grease rise to the top of the wastewater. The waste material that settles down at the bottom is called the sludge, and the floatable material is called the scum. Scum is then removed using a skimmer, and sludge is removed with a scraper every few days. The water that is left out is called the clarified water. In the secondary treatment process, biological or organic wastes are removed. It is a biological process. This is done by transferring the clarified water into an aeration tank, where air blowers bubble air, which helps the aerobic bacteria to grow and feed on the organic contaminants such as food waste, feces, and other organisms. The mixture then flows from the aeration tank into the clarifier, where activated sludge settles out by gravity. The activated sludge so produced along with the sludge produced in the primary process is transferred to the digester, where it is decomposed by anaerobic bacteria. Biogas is produced in this process, which can be used as fuel or can be used to produce electricity. The activated sludge is then left in the sand drying beds. Some quantity of water in the activated sludge evaporates and the remaining quantity drains through the sand beds. This leaves behind the remaining dried sludge, which can be used for making fertilizers or compost. In the tertiary treatment process, the leftover wastewater is treated with chlorine to remove the phosphorus compounds, nitrogen compounds, and bacteria. It is a chemical process. Chlorine tablets are added to kill the germs. This process is called chlorination. Then this water is let off into the water bodies.
Okay, so that's the process class of wastewater treatment. Um, so that's it for our week one for the final term. So if you have any questions or clarifications, you can send an email to me directly or send a PM in Facebook. So class, so I hope you're all doing fine, and see you next week. I'll post our activity in our Facebook group.